Today we're going to take a look at the inverse of functions. And the inverse of a function is the relation formed when the independent variable, and usually when we're graphing, that's our x coordinate, is exchanged with the dependent variable. So what we're going to do is you should have a foldable here. Oops, that's the assignment. Let's see. Right here that says finding the inverse. And again, I can't lift up these flats, but you will be writing it underneath each of these flaps. So you'll cut it and then write this underneath. Now, one little notation note, as you guys will see right here, finding the inverse, this is our notation for what we found the inverse, f to the power of -1. So the first thing we're going to talk about is how do you find it from an ordered pair or table? Well, let's say we have 3, 6 and -2, 4. We exchange the independent and dependent. So if we do that, that becomes 6, 3 for this one, and 4, -2. We're just switching those around. Now from the graph, so you guys will also have handed out all these different graphs here. And let's see, let's take a look at some of these. So 1, 2, 1, 2, 3, 4. So this is the coordinate 2, 4. So that means on our other graph, let's see, 1, 2, 3, 4, 1, 2. And let's see, let's get another one. So we have 0, 2. And you'll notice then that becomes, that was 0, -2, excuse me. So we have -2, 0 over here. So they're all switched, but some of you might notice these may look a little symmetrical. And what they are is if we were to draw in the line, this diagonal, it's a reflection over that line. So we have this line here of y equals x, and it's a reflection across there. So from a graph, you can find it a couple ways. You can switch x and y, and you can reflect over the line y equals x. Now if we had to find it from an equation, and we're going to take a look at a couple of these here. So our first example here, from an equation, let's say I had f of x equals 4 minus 3x. Well, we know from before we have to switch x and y. So this f of x is usually, that's the y. So this becomes x equals 4 minus 3y. And we're not going to leave it like that. We're going to solve for y. So minus 4 minus 4. So we end up with x minus 4 equals -3y. Divide by -3. So now we have x minus 4 divided by -3 equals y, but we're going to use that inverse notation. So instead of y, we're going to write that that's our inverse there. Now the second one we're going to look at, let's try this one. F of x equals 3x minus 2. So again, this becomes x equals 3y minus 2. So we are going to solve for y. So we add 2. and then we divide by 3. And then we have our inverse. So those straight linear ones are pretty easy. So we're going to take a look at a couple nonlinear. Let's say we have y equals 3x squared, and we're asked to find the inverse. So x equals 3y squared. Divide by 3. X over 3 equals y squared. Then we have to take the square root, but we have to remember to plus or minus when we're taking the square root. So x over 3 equals that inverse function right there. And the last one we're going to take a look at. We're going to take a look at one with some fractions. So let's say we have f of x equals x over 3 plus x. So the first step should be pretty easy now. Switch to x and y. So x equals y over 3 plus y. But we haven't dealt with this before where we have y's on both sides. So, well, let's make this so we don't have a denominator. So let's multiply each side here times 3 plus y times 3 plus y. So now we have 3 plus y times x equals y. Well, that's nice. Now we don't have a fraction here. Let's get rid of these parentheses. So now we have 3x plus yx equals y. Well, our goal is to solve for y, so we have to get y on the same side here. So minus yx minus yx. So now we have 3x equals y minus yx. So we're getting closer. So the next thing we can do on this side is we can factor. So factor out of y becomes 1 minus x equals 3x. And this is kind of nice because now we can just divide by 1 minus x, divide by 1 minus x, and we have 3x over 1 minus x equals our inverse.